This is an introduction to conics. And so the four main types of figures that you will be seeing are parabolas, circles, hyperbolas, and ellipses. And so really, it's important to understand conics because when you look later into the polar system and everything, we will be identifying which shape is exactly a parabola, or which shape is a circle or a hyperbola or an ellipse, depending on the polar equation. Again, the polar system is just a different method of measuring. So instead of like the rectangular system, which we utilize in the form of x comma y as the coordinate point, you have something like r comma theta. So it's just a different notation, a different system. And so again, but this one has nothing to do. That will be more of polar. Again, a major component of pre-calculus conics here is just these four. Understanding more about these four types of figures: parabolas, circles, hyperbolas, and ellipses. So obviously there will be things to do with graphing, understanding equations, and all of that. Here in this introduction, we'll just be going over how to identify which, by the equation, the type of figure that your equation is representing. So for parabolas, right, if you do remember, real long time ago, or long back, I had a lesson on quadratic equations, and that lesson did cover the vertex form and all of that. And really, those were the parabolas, because you had something like y is equal to x squared, y is equal to x squared plus 3. So those are the parabolas, the shape that goes like the U shape, or it could go like that. And so that's the form. Again, the parent function would be y is equal to x squared. So that's a problem. But now when you're talking about the vertex form, we're really looking at y is equal to a times x minus h squared plus k, and where h comma k is the vertex of the parabola. So that's an important form that you want to know. If you see something in that form, then you must understand that that is a parabola. So you can have the standard form, something like y is equal to ax squared plus bx plus c, but this is another form that you should know. You can easily see the vertex when it's written in this form, and you know that it's a parabola. With a circle, so circles, again, we think that they're pretty simple, but when you look at their equation, it's still not that complicated. So looking at this, the thing with them is it's x minus h squared plus y minus k squared is equal to r squared. Now here we know that the h comma k in terms of parabola was representing the vertex. So here, however, with circles, h comma k is the coordinates of the center. So your center is h comma k. That's what this is representing. So it's x minus h squared plus y minus k squared is equal to r squared. And again, r is the radius of the circle. And so with ellipses and hyperbolas, so again, they have a form that's much more complicated, and it can get confusing when you're looking at the form, because it has it doesn't have multiple variables, but there's more division, and when you graph it, it also looks a little bit complicated, because you have horizontal hyperbolas, and you have vertical hyperbolas, and you have vertical ellipses, horizontal ellipses. So for these two, I will be talking more about them in a different lesson. So just looking at parabolas and circles, these are the two main equations that you should know. Now if you want to identify, just based on the equation you have, for instance, let me see, you have something like x squared plus y squared plus 16x minus 6y minus 11 is equal to 0. So looking at this, and you just want to identify which conic this equation is representing, your answer should be that this one is a circle. And if I give you another one, 4x squared plus 4y squared plus 12x minus 16y, I don't know, is equal to 20 or something like that, your answer will be circle again. And do you see a pattern? The pattern is that looking at the equations for a circle, the coefficients of the x squares and the y squares will always be the same. So the coefficients of the x squared and the x squares and the y squares are the same. So here they're 1, which are obviously identical, and here you have 4. And so knowing that the coefficients are equal, you can state that yes, this conic or this equation is representing a circle, and again, a circle is a conic. And so, and now looking at something else, I guess I can really introduce the concept of ellipses now, the shape of ellipses. So if you had something like 5x squared plus 3y squared, or you have that addition sign, right? You have the addition sign, however, the coefficients are not identical, then it's an ellipse. So you can have something like 5x squared plus 3y squared, right? Or something like that. And that will be an ellipse because you have the addition sign between the x squares and the y squares, but your coefficients are not the same. If they were the same, then you know that it's a circle. So they have a correlation because both have an addition sign between those two terms here, the x squares and the y squares. Looking at the hyperbola, it's easy to tell if it's a hyperbola if you have the minus. Don't really care about the coefficients here, it's just if it has the minus. If you see the minus sign in the standard form, or if the form of the equation is given something like this and you see a minus sign, for instance, I don't know, 5x squared minus 3y squared, then you can state that this equation does indeed represent a hyperbola just because you see that negative sign or the minus sign. And with parabolas, again, this was the equation, but again, if you're given something like this, a random equation that gives you the x squares and the y squares, if you see that it has an x squared and a y squared, then it is not a parabola. In order for the equation to be representing a parabola, you must see an x squared or a y squared. You cannot see both x squared and y squared. It can be one or the other. If you see both, then it cannot be a parabola. So just going, you can obviously review those rules. So that's just identifying the type of conics. And so here I can just give you one example, I guess. So something like this. So I have x minus 2 squared plus y squared is equal to 16, right? And if you look at this conic, really expanding this out, you know that this has an x squared, right? Just an x squared, its coefficient being 1. Similarly, the y squared has a coefficient of 1. Therefore, this is a circle, and it is a circle, and the center must be h comma k. And looking at this, this indicates that it must be 2 comma 0. Why? Because again, h is really, so it's x minus 2, that's why it's x minus h here, and so really your h, right, or the x coordinate of your center must be 2, and your y coordinate must be 0, so it's 2 comma 0, that's the center point. Now you have 16 as r squared, therefore your radius must be 4. So this circle has a center 2 comma 0 and a radius of 4. Now again, something to do more with circles, you may be given something like, again, I think this was one of the previous equations I had showed, so x squared plus y squared plus 16x minus 6y minus 11 is equal to 0. And so looking at this, the thing with this is that you have x squared plus 16x. Now you want to put this into the standard form. You know it's a circle just by recognizing that the coefficients are identical, right? They're both 1, 1. So therefore it's a circle. But how do you exactly put this in the standard form? If you recall from, again, one of my previous lessons, you can, really the best way here that I would recommend is completing the square. You see x squared plus 16x, right? So you can divide 16 by 2, that's 8. The rule is b divided by 2, and squaring that. So 16 divided by 2 is 8, squaring that is 64. So you have x squared plus 16x plus 64. So we're adding the 64 here, right? And you want to make sure that so you're adding the 64 here, and then with the y squares, we can also do the completing the square, because if you look at this, negative 6 divided by 2 is negative 3, squaring that's 9. So here you have y squared minus 6y plus 9, and again this thing has been added. And so now you see 0 here, right? And we don't want to forget this negative 11 here. So we can move the 11 on the other side, or you can assume that that was done before. So if we have 11 here, we must also add 64 and 9. And so that's 75 plus 9, which is 84. So this over here must be 84. And if we if we factor this out now, we know that this is x plus 4 squared plus y minus 3 squared. That's giving us 84. And now if you look at this, again, you see that it's the standard form of a circle. The center being negative 4, comma 3, that's the center of the circle. And obviously the radius in this case would be the square root of 84 units. But this is the standard form. And when I mean when I say the standard form, that's this: y is equal to x minus h squared plus y minus k squared is equal to r squared. So this is what we have. But just identifying, you can identify that it's a circle just by telling that the coefficients are identical. So thanks for watching.